The next presentation that we have is from Jussi. I think we've had a few presentations where we've kind of like gone from like the deep dives that we've had to zooming out a little bit more. We had one from George yesterday and one from Edmund earlier on day one. So it's a very interesting talk about the complexity. Where does it come from? Over to you, Jussi.
So my name is Jussi Pakkanen, and I'm the project lead for the Meson build system. And the talk I'm going to be having today is not so much practical, it's more of like a philosophical thing. And it's mostly about complexity. So let's do a thought experiment. And let's create a brand new build system, like completely from scratch. We can avoid all the old mistakes, start from scratch, do the right thing. So what would that look like? So what it needs to be is that it needs to be general and it needs to support all languages, or at least be able to support all languages. All the common platforms, most of the uncommon ones, all the common use cases people might have for building stuff, for like embedded and applications and all those sorts of things. And the basic idea is that there are very few people who should be able to come back to say, okay, I can't use that because it doesn't do the thing that I need. Now, obviously, you can never do everything that everyone needs, but this would be very rare. So only a very small people, because if there's lots of people who say that you can't use that, then they're not going to adopt that and they're going to use something else. When you start working on this, you probably need some sort of compiler abstraction or a base class if you're into object-oriented programming. And then the question is that how many implementations or like a backend for this thing would you need to have? And in Meson currently there's about 30. And they're not almost the same. They're very, very different. So the things you need to do to the D reference compiler compared to GCC is very different. And this is actually quite uncommon in software development, because if you have multiple backends, it's very rare that you have more than 5. Like if you do SQL, you might have SQLite, Postgres, Oracle, and Microsoft SQL, but that's about it. So having 30 different implementations of something is actually quite rare and uncommon, and that makes it hard to design. And then you get other interesting questions, like when you build libraries, should they be shared libraries or should they be static libraries? And there are very strong opinions on this. So if you talk to people who do package management on Linux distributions like Debian or Red Hat, the thing that they will say is that here at Linux distribution X, we require that everyone uses shared system libraries. So that's what everyone should always be using. On the other hand, we here at big web search company use static self-built libraries. So obviously that is what everyone should always be doing. There's various levels of condescension depending on who you talk to. But from a build system perspective is that you must provide both. And they need to be like integrated from the beginning. Because if you tell people that you need to re-architect your entire build infrastructure, which may have 20, 30 years of history, to behave the way I want it to behave, other than what you have and what you want to do, that's not a winning move. It's probably not going to happen. And then where should dependencies come from? Should they come from the system packages I mentioned earlier? There are language-specific package managers, maybe they come from those. There are third-party package managers. There's like things like Conan and VC package, which come from that. Vendor monorepository, that's a common thing. You just take all the sources, put it in your own, and pretend that it's your own code. Maybe it's independent subprojects. You have Git submodules that are integrating your thing, and these sorts of things. And these are, again, all of these must be supported, because shooting yourself in the foot is very easy, because there's many different ways in which dependencies can swim into your system. So as an example, furthermore, the things you depend on are going to get the dependencies in a different way that you are going to use them. But still what you would want to do is, okay, there's a dependency over here, I'll just take it here, put it as part of my thing and use it, and it should just work. And if you have like a big monorepository which has 100 of your own dependencies with the exact versions that you need, and then, okay, now I want that one over there. And that dependency is also provided only as a monorepository, which has its own dependencies, but the versions that they have chosen to be exactly the correct ones, which clash with yours. You're not going to have a good time. So how would you tackle this? Because this is a 10-minute presentation, there would have been a lot more stuff here, but in the interest of brevity, I have to move a bit faster. My slides seem to be slightly in the wrong order, but anyway, one more thing is that a lot of new build systems that they are very oriented towards building apps. In whatever app means, like build your Docker container stuff and so on. But if you do system level management, that is the very packages that make up an operating system, then you get interesting requirements that a lot of people don't actually know about. And as an example, when you get really, really, really low, the thing that your build system needs to be is that it needs to be bootstrappable to new CPU architecture. So what usually happens is that very small core packages get built, cross-compiled to the new CPU architecture or whatever it is, and then you self-host from there. And this is a requirement for things like Debian. And every single dependency that your build system brings in is a problem because that increases the size of the bootstrap set. So that means that your build system, if you want it to be general and used by all sorts of people, it can't be implemented in Haskell, it can't be implemented in Java, it can't be implemented in any fancy new language. And if you go to extremes, you should not even use Python. And the only things that you should use is plain C and Perl. And that's like if you want, I think that if you want to get stuff into FreeBSD core, the only things that you can depend on is C, Perl, and Shell. And if it's anything else, can't be used. And then, like, how would you, the typical is, okay, we have lots of complexity here. Let's add toggle switches because toggle switches solve everything. And then you have 1,000 different project options that you need to fiddle with, and you can't ever tell if anything is right because no one has tested the 1,000 different combinations of things that you might have. So how do you, so this is where the how would you tackle this slide should have been. So the way to solve these sorts of problems is that you find orthogonal components, like things that you can define that don't depend on each other. And Messen does most of this. We need to do even more. The reason we didn't do these things from first principles first time is that some of these were only learned as we went along. But anyway, so there are two of the main components that there are. The first one is what is called as the DAG, which is basically what files go into which targets, which target depends on what depends on what. How do you generate source files that you then build? And this is what classically was in the makefile. The original point of the makefile was that you just write these things and then things happen. And this is a thing that rarely happens. So if you have an executable and use a library, it's probably not going to change, right? It's very unlikely that you change the dependency on that. It's very rare. So this is a thing that you really depend on. It's very static. And this is what you have in version control. But then the other component, which is completely, almost completely separate, is that how do you configure this? So how you have a build type. How do you get your dependency? So the fact that you have a thing that has a dependency is static, but how you get that dependency can be completely dynamic. It can change at runtime, and different people have completely different requirements on how it should be done. And this is very, very dynamic. It changes often. If you have multiple build directories, it's typical that different build directories have different options for many of these. And this is a transitory, and you just, if you don't need some build directory anymore, you can delete that, and all of that goes away. And this is rarely committed to version control. You can have like presets which you type, but this is the thing that you really need to fiddle with a lot. And furthermore, this is something that should be toggleable from the command line. These are the options that you should be able to set without editing any text files. And these are the two things that you need to keep as far apart as each other as possible. Because if you mix them, then you get problems, because now you have static and dynamic data, and they're intermingled together, and then you're not gonna have a good time. And if you look at the way build systems typically are defined, is that there's a single build definition file, and everything is in a common namespace. And this works against the split, because if they are in the same namespace, if they can be intermingled, then they will get intermingled, because that's just the nature of how things work. And if you didn't design for this in the beginning, then retrofitting is really, really difficult. I'm gonna say impossible, but it's like really, really hard, especially if you want to maintain backwards compatibility. And if you look at where build systems come from, the most common nowadays seems to be that there's a group or an organization or a company that have a very specific need. And the existing tools don't cater for that need. And then they decide, okay, we need to define a new tool for our specific use case. And this is what drives the design. And this is, we'll find that where all the complexity comes from, is that if you want to create a very widely usable build system, then it requires that the design focus throughout the entire life cycle of the project is catering to fulfilling requirements that you don't have and would prefer that no one else had either. It's very common to like how do I do this? And then people say, no, you should not be doing that. And this is a bit of a problematic thing. And if you look at like how companies work and how they run open source projects and so on, typically what they want to make is like they have to have their own thing, and they want to maintain their own thing, but also have other people use it. And the problem is that then if you don't give out the control and be willing to change, you really can, and then it gets very problematic. So that's basically what I had. So if there are any questions, go ahead and ask them.
Jussi, thank you very much for that. That's a very interesting presentation. And yeah, I think one that it's that zooming out that I find particularly interesting with this. So one of the things I think you said a few minutes ago about build systems that generally focus on the application level and some of the requirements that they have. And I think that it's fair to say that we've actually had quite a few build systems that we've been talking about over the last couple of days. Just wondering what your view on that was, particularly with relation to your comment about the language requirements for this new build system being very low level.
Right. Well, there's two different levels to that. There's one that is the actual requirement, that's imposed by the core infrastructure, and then there is the other, which is what do people actually want. And one of the unfortunate things is that if your build system is written in Java, then on its own, no matter how good it is, no matter what it does, there is a sufficiently large group of people who say that I'm not going to touch that. And these are also the people who create most of the low-level stuff. And this, you can see this. So if you look at something like Bazel, last I checked, it wasn't packaged in Debian and it wasn't packaged in Fedora. So you can't even use it if you want to.
I think the Debian packaging might have changed very recently, but
okay, well that's good then. Like, is it in the actual archive? Because if you have third-party packages, then I think those have been available, but it's not the same thing because you can't depend on it inside the thing. But if it's now packaged, great.
Thank you very much for your time. Thank you.